Here given A is equal to rho cos phi A rho plus Z sin phi AZ. So this is in a cylindrical coordinate system. So we have to find the line integral of A. So in this particular diagram, if we divide it into three parts, where the integral in the x coordinate is given as 1, and this particular integration is given as 2, and the third one is given as 3. So we'll try to do it in three different parts, 1, 2 and 3. So the first one we are taking as C1, the area is taken as C1, which is given by, here this is an xy coordinates, whereas the question is asked in cylindrical coordinates. So the value of z is taken as 0, and along x coordinate, along x, the value of phi is equal to 0. And here we have only the change along x, which is the change along rho, which is the radius. So C1 is given by change in the radius from 0 to 2 into A into this, the change is around d rho radius into A rho. So A, we have two parts here, we have A rho part and AZ part. If we perform the dot product of A rho with A rho, it's equal to 1, and if we perform the dot product of A rho with AZ, it is equal to 0. So we consider only the first part. So it is 0 to 2 rho cos phi to d rho, where the value of phi is equal to 0. 0 to 2 rho d rho is equal to rho square by 2, 0 to 2, the value is equal to 2. Now we are taking the second part. So C2 is equal to, here the change is in phi direction, where the angle covered is from 0 to 60 degrees. So the change is in phi direction. So 0 to 60 degrees. 60 degrees can be represented by pi by 3. So A into rho d phi A phi, where A phi is the unit vector along the azimuthal angle. So here, if we consider the vector given, here A phi component is missing. So if we perform A phi component with A rho, the value is equal to 0. And similarly, if you see the dot product of A phi with AZ, it is also equal to 0. So the value will be equal to 0. C3 is equal to, here, if we consider the third part, the value of rho, which is the radius, which is given as 2. So this value of radius is going to come from 2 to 0. So we take it from 2 to 0, the value of A into, once again, d rho A phi, which is equal to, if we take the value of A as rho cos phi, where the value of phi is equal to pi by 3 in this case, into d rho 2 to 0. Pi value is pi by 3. If we substitute, it's equal to 1 by 2. If we take it outside, it is 1 by 2. Rho square by 2, 0 to 2, 2 to 0. If you calculate, the value will become to minus 1. The total integral A dot dl is equal to C1 plus C2 plus C3, which is equal to 2 plus 0 minus 1 is equal to 1. So the answer is 1.